Welcome to this Discovery Summit presentation. My name is Holger Specht. I work in the analytics department at AMS Osram, and I use JMP for exploratory data analysis really 24/7. And in this presentation, I want to show you some helper tools which you can use for exploratory data analysis. So here, this picture really shows how JMP can be used to interface data directly with the human brain. And here I have an easy example where I can show you how powerful it can be. It's a very simple children game. So you just have to find the way from the entrance to the exit. So when you get stuck in a dead end, you turn back and find your way through the maze. That will take some minutes for a kid, and I think it will also take some minutes for an experienced analytics guy. But there are some cool tricks that can speed up this process, and I want to show that. I developed a tiny script that works like a paint bucket in a graphics tool. And when I use that and click here on one point, then JMP will find neighboring points and color them, so here in black. And it will continue to find those points till it found all the points which belong to this wall. And that we'll see in a second. Okay, now it finished. And now you see that there are two walls, a black wall and an orange wall. And now you can go from the entrance to the exit within seconds. So really the human brain now really finds the way here really quickly from the entrance to the exit. And you just have to stay between the black and the orange wall. And also nice, so if you have two black walls or two orange walls next to you, you know that it's much faster to go back to the entrance and then to start again. So how can that be done in JMP? So easy trick. So you need the script and two extra steps. And the extra steps I want to show you. The first step is you have to download the image to table add-in from the marketplace. It's programmed by Chad Campbell, and here you just have to click on download and install that. And then you can open this add-in. And the add-in, there you can select an image like the maze, and then you can import it. So here the maze is still a graphic, but when you click on import, JMP will convert this image to a data table and also show a graph that is related to the data table. And now we have this link between the graph and the data table. And when I select data points here in the graph and go to the data table, they are automatically also selected in the data table, and vice versa. I can also select data points here and they will be selected here. And now the final step is this paint bucket. So in a graphics program, the program knows the X and Y coordinates, and it knows for a point what are the neighbors. But JMP doesn't know that. So it just knows these rows, and it knows, okay, there is an X and Y coordinate, but it doesn't know which row is a neighbor of another row. And so we need this intermediate step to tell JMP where are the neighbors. And that can be done with another add-in. So that is the Quick Select toolbar. And one of the buttons in the Quick Select toolbar does exactly this job. So if you want to get the Quick Select toolbar, you have to go to the community, go to the add-ins. And in the add-ins, there is this Quick Select toolbar, and you can download it here by clicking here. And then you just have to activate it by right-clicking here in the toolbar area and selecting Quick Select. And this is the button that we need, so the neighbors. And we just have to select the coordinates. And we want to have the direct and the diagonal neighbors. So let's click on OK. And then JMP takes a while so to analyze the coordinates X and Y and check for neighbors. And then it will merge the data back to the data table. And in some seconds, it will finish. Okay, and here it is. So we have now a column with the direct and diagonal neighbors. And as an example, so make it a little bit larger. So let's go to row number 5, and we see that row number 4 and 6 are neighbors. So this is clear from the x and y coordinates. But there are also in the 300s some other neighbors of this row. And with this additional information, we can go back now to this graph and use the paint bucket tool. So this time, maybe we select the top wall, and now jump again, searches for neighboring points which belong to the same wall and colors it. And at the end, we will have the two walls with the different colors. So quite powerful, and compared to the children approach that you really do that by hand and find every dead end. So this is really much faster, and I think the time that I needed now to explain the tool was not much longer than the time that the kid would need to find the exit. And with every new maze, there is a huge payback then, because then you can really solve such a maze in seconds. So quite powerful tool here. Let's have a look also at the other functions here. So for example, when we zoom in to this arrow and mark the arrow, so we could label this arrow by clicking here and typing arrow. And when we look at the data table, there's a new column with zeros and ones. And all the rows that belong to the arrow are then ones, and the others are 0. So this is quite easy. There are also two other ways to label data points. I want to show this label function. So let's also write here arrow. And here in this case, column with property multiple response is added to the data table. And here we see that these points belong to the arrow. And because it's multiple response, we can now collect additional information here. And so let's zoom out here and maybe change the information that we see. So that was the color with the vector, the column with the vector with all the neighbors. And we can count these neighbors. And here is the number of the neighbors. And I want to use this as a nominal value and maybe put it on the color. And maybe also put it on the red. And here you see now the different types of points. So there are points with 8 neighbors, and these are the points within the wall. So they have really 8 neighbors, but there are other points which just have 5 neighbors. And so let's open again the legend and select those points. And I also want to label those. So let's use again this tool. And in this time, we say 5n for 5 neighbors. And so now we have the 2 labels. And so we see here that in the arrow, there are also some points with 5 neighbors. Just select the arrow. And here we have then both labels. It's part of the arrow, and the point has 5 neighbors. So this is much better than the way before, because now we really can collect all these informations. And now let's go to another dimension, like for example, with these color coordinates. Let's use the red channel and the green channel and look at the individual points. And here, so it seems that there's a twofold distribution. So let's mark one of the distributions and label it. So now we can go back to our graph And instead of the number of neighbors, we remove that again. We take our new column with the labels, and since jump 16, the graph builder can understand this multiple response property. And when I use it here in the graph builder, we see here now that for every label, a separate graph is generated. And now I can select data points, and the corresponding data points will be then also selected in the other graphs. Here we see that some of these points are also in this subgroup and in this subgroup. And to facilitate this a little bit, I use another button. So this is a very nice button here. So this is similar to this black button, but what it does is whatever I select, it will be set to 1. So this is quite powerful. So now I can use this column to separate between selected and unselected points. And let's use this button or this column here as a color. And now I can select data points, and the selected data points in the other plot are also are then highlighted with this separate color. And so now, for example, I can select here all the data points with main color. And now the data points will also be selected in the 5N and in this arrow group. And the last icon that I want to present you is this invert button. And when you click on the invert button, then the inverse of the selection is then selected. And the graph really likes our analysis. So it seems that we found a hidden secret in the data set. And when you found such a secret, you want to share that with your colleagues. And the easy button to do that is this PowerPoint, send to PowerPoint button. You just have to click there. And if there is a PowerPoint presentation open on your system, then the graph will be automatically added to your PowerPoint presentation. And even better, so when you press Control and click on the graph, then you can come back to your data table. And in this data table, a new script group is generated. And then you have here a script to recreate exactly the graph that was sent to PowerPoint. So if you have a presentation from half a year ago, and if you want to find out how the graph was generated, this will save you really half an hour. Okay. So let's come back here to the main presentation. So we discussed about the quick select toolbar, and I showed you some functions already of the graph builder toolbar. So actually, it's just an extension of the report toolbar. So these 3 icons you might know from the report toolbar. And after installing the graph builder toolbar, you will have more icons available in this report toolbar. To install it, you just have to go to the marketplace and download this toolbar, and then come back to JMP. And so if you want to add this toolbar, just right click here and select the report toolbar. And at first, it will show up at the top, and you can right click here again and change the location to left. And then this toolbar will be here. So I already showed you the send to PowerPoint, and I used several times this open and close command. So let's go again to a plot like this. So when I click here, I can open the control, and when I'm finished, I can close the control. And here, I think in this case, we just have a single point. Here it's a little bit boring. But when we take again these neighbors, then sometimes we want to have this legend accessible to change the colors, and then the legend doesn't help so much. And then we can just hide it, close the menu, and then share the plot. And then maybe some minutes later, we want to change the color, then we just have to click here, have access to the legend again, and whoops, sorry, close it again. So there are many more icons, and due to time constraints, I don't want to show them all in detail here in this presentation, but come to the Discovery Summit in Berlin, and then we will discuss there. So there is a last add-in that I want to show you, and that is the Normalize toolbar. And again, like the Graph Builder toolbar, you just have to go to the marketplace and can download it from there. And then an icon will show up here, and it's also in the columns menu, Normalize. And let's open this data set. It's weather data versus time. So here we have a plot versus the time of several measurement stations. And we want to normalize it a little bit. And so we could select here some data points and use our new quick select toolbar and say reference. So we have here now a reference area, and we want to normalize every single curve by the values in this reference area. And to do so, we can use here this average here, and we need the reference as a reference. So we pick this column, say, okay, we want to use the entries with a 1 in this column as a reference, and we want to normalize by station. And after setting all the settings, we can apply and close this menu, open here this menu, and use this new column on the y-axis. And now we normalized every curve to the values here, and we see, so yeah, in spring there's an intersection, and then in autumn there is another intersection. So with this example, I want to close here and highlight again how useful JMP can be to access data with the human brain. Thank you.